Okay, so in this video, I'm going to be going over what is actually called section 2.3 in your assignments, but it's titled The Composition of Functions in Pearson for your section 2.3 assignment. So in this section, we're going to be learning how to find the composition of two functions and what that means. And then also how to find the domain of those compositions. And then we're going to learn how to kind of go backwards and decompose a function that is a composition of two functions. So first of all, the composition function, which is written like this, and the way we read that is f of g. And this is the composition of f and g. And what this means is, so another way we write this is f of g in parentheses and then of x. So this is f of g of x. And so what this tells us to do by definition is it tells us to take g and plug it in to f. So that's why this can also be written like this, where we have the function g of x, and it's written inside the function of f. Just like if I asked you to find f of 2, this tells you to plug 2 in to the function f everywhere you see x. That is what this means. So this is actually also a composition of two functions. If they told me that f of x is equal to, I don't know, x plus 1, and then they told me g of x is equal to the constant function 2, then f of g of x would be the same thing as f of 2, which would tell me to plug that 2 into x, into the function f. So that's all this means. It's the same thing as just what we learned here when we would put an input into x. This is going to tell us to put a whole function g of x into f as an input. All right, so for example, let's say they gave me the function f of x equal to 2x minus 5 and g of x equal to x squared minus 3x plus 8. And the first thing we want to do is find the composition of f and g, which again is the same thing as f of g of x, which is the same thing as taking g of x and plugging it in to f everywhere we see an x. So I can also rewrite this as f of x squared minus 3x plus 8, since that's what g of x is equal to. So far this is just all notation. It's just kind of telling me what to do. So now I'm going to take everything that's in g and plug it into f. So this would be equal to 2 times x squared minus 3x plus 8 minus 5. So again, that's just me taking g of x and plugging it into f everywhere I see that x. Then of course I would distribute this and simplify. To get this as my final answer, which is 2x squared minus 6x plus 11. Okay, so now we're going to go to the next slide and find g of f of x. So again, we have f of x equal to 2x minus 5 and g of x equal to x squared minus 3x plus 8. So now this is the composition of g and f, or I would read this as g of f of x. And so this is going to tell me to take f of x and plug it in to the function g everywhere I see an x. So just notation-wise, I can replace f of x with what it's equal to, which is 2x minus 5. And then I will plug that in everywhere into g everywhere I see an x. So that will be 2x minus 5 all squared minus 3 times 2x minus 5 plus 8. And then I would FOIL the first binomial to get 4x squared minus 20x plus 25. Distribute this negative 3 to get negative 6x plus 15. Bring down my plus 8. Combine like terms. To get 4x squared minus 26x plus 48 as our final answer. Okay. So let's do another example, and this time we're going to find the domain of the resulting composition function. So in this example, we have f of x equal to the square root of x, and g of x is equal to x minus 3. And so first we're going to find f of g and g of f. So for f of g of x, we're going to take g and plug it into f. And g of x is equal to x minus 3. So I am plugging x minus 3 in for x everywhere in f. And f of x is equal to the square root of x, so this would be the square root of x minus 3. And that would be simplified, so I can't do anything else there. And let me see. Okay, just making sure I was doing that. Okay, so before we talk about the domain of this first composition function, let's find the next one, g of f. So g of f of x is telling me to plug f of x into g everywhere I see an x, and f of x is equal to the square root of x, and g of x is just equal to x minus 3. So instead of x minus 3, I will be plugging in the square root of x into x, and so that'll be the square root of x minus 3. And that is simplified. So now let's talk about the domain of these. And if we just look at the graph of the first one, the square root of x minus 3, then we can clearly see that the domain of this function is going to be equal to 3, infinity, because the x values start here, which is at positive 3 for x, and it's included, so it gets a straight bracket because it's clearly there's a point right there at x is 3, and then it goes off in the positive x direction forever. So that would be the domain of this function. And let's just talk about the range for a reminder. So the range, if I'm looking from bottom up, the first y value that's associated on this graph is going to be y equals to 0 right here. So the range starts at 0 and goes to positive infinity. But let's just talk about how we can find the domain of f of g algebraically. So remember, f of g was equal to the square root of x minus 3 from the previous slide. So if I wanted to find the domain of this function, then I need to talk about the restrictions of this function. So the restrictions, or the restriction on this function, is that we cannot take the square root of a negative number. So the only values of x that are in my domain are going to be the values that make this function, that make this expression here, x minus 3, greater than or equal to 0. And if I solve this inequality, I get that x is greater than or equal to 3. So this is actually my domain, because I cannot plug a number in there for x that makes that expression negative. So my domain will start at 3 and go to positive infinity. And that's exactly what we got by looking at the graph. And then for the second function, g of f, we got the square root of x minus 3. And to talk about the domain of this function algebraically, the restriction here, again, is the same thing. We can't take the square root of a negative number. But here, the only thing under the square root in this function is x. So that tells me that x has to be greater than or equal to 0. So the domain would be from 0 to positive infinity. And if we look at that graph of g of f, we see that that's true. So the domain, the x value starts here at x is 0 and goes off to infinity. And the range for this graph, the y value starts at negative 3 and goes to positive infinity. Okay, so now we're going to just learn how to do this kind of backwards, how to decompose a function that is a composition of two functions. So for example, if we have a function h of x, and it's equal to 2x minus 3 all raised to the 5th power, and we're asked to find functions f and g such that the h of x is equal to the composition of f and g. And again, remember, this notation means f of g of x. So I'm trying to figure out what g of x could be and what f of x could be in order to create h of x. So the best way to go about doing these is to look at the original function they give you here, 2x minus 3 all raised to the 5th power, and think about what looks like the inside piece of the function. So what do I mean by that? Let me erase this real quick. So if you look at this function, 2x minus 3 is inside these parentheses. So I would think that that would be my inside function, because it's all being raised to the power of 5. So it's inside of those parentheses. So that could be my g of x. So let me write that here, 2x minus 3. And then once you kind of pick the piece of the function that you think is the inside function, replace that inside function here, so all of that, with just x. So that would be x to the 5th power, right? So let me write x to the 5th power here for f of x. And then you just kind of try it. So that's what they have down here, by the way. F of x equals x to the 5th, g of x equals 2x minus 3. So once we kind of test it, we're going to just see, okay, does h of x equal f of g of x? And I have chosen g of x to be 2x minus 3. So let me plug that into what I said was f, which was x to the 5th. And so that would be 2x minus 3 to the 5th power. So that's correct. So you're just kind of trying to move backwards and find the missing puzzle pieces here to make that composition function. All right, I have 2 more examples here that I just want to kind of do real quick, just to make sure we're understanding these for our homework. So my first example is giving me h of x and saying that that's equal to x minus 3 squared plus 1. And it wants me to find f of x and g of x such that h of x is equal to the composition of f of g. So this is just what we were just doing. So again, that notation, f of g, is the same thing as f of g of x. So I'm trying to find the inside piece of this function first. So if I look at h of x, and I'm trying to see which part of this function looks like it's inside of something, well, I would say that would be x minus 3. It's inside of the parentheses. It's all being raised to the exponent of 2. So let me just try to let g of x equal x minus 3. And then f of x, if I'm choosing g of x to be x minus 3, then f of x, the outside function, I'm going to replace that x minus 3 with just x. So that would be x squared plus 1. And then let me just check to see if I did it right. So h of x is supposed to equal f of g, which is f of g of x. And I just chose g of x to be x minus 3. And if I plug that into what I said f of x was, that would be x minus 3 all squared plus 1. And that is what h of x was. So I did it right, and this would be my final answer. Okay, last one gives us f of x equal to 1 divided by x, and g of x is equal to x minus 3. And it wants me to find f of g and g of f and state their domains. So f of g is the same thing as f of g of x. And g of x is equal to x minus 3. So now I'm going to plug x minus 3 into f everywhere I see an x, so that would be 1 divided by x minus 3. And let's talk about the domain of this. So I think about the restriction on this function. And the restriction on this function is that we cannot divide by 0. Therefore, x minus 3 cannot equal 0. And the value that will make that equal 0 would be 3. So x cannot equal 3. So everything else is fine. So the domain in set notation would be the set of all x such that x cannot equal 3. Or the domain is all real numbers except for x equal to 3. Okay, the next one is g of f, which is the same thing as g of f of x. And f of x is equal to 1 over x. So I'm going to plug 1 over x into g everywhere I see an x. So that would just be 1 over x minus 3. And the domain here, think about the restriction. So there is a fraction and there's a variable in that denominator. So the same restriction applies. And in this case, x cannot equal 0. So the domain is the set of all x such that x cannot equal 0. All right, and then finally I'll be uploading a video for section 2.4.